Hi, my name is Jazz, and in this video I'll be talking about my big project, Quarter 2, Grade 10. So the title of my project is Real Life Parabolas, Water Arcs, and this project or video will be working on the water arcs or quadratic functions from water. I'm from Niva International School, and this is my name. And the contents of this template are introduction, which I'll be talking about like how I did it and what I've been through, what are the limitations, the methods, results, discussion and conclusions, common core standards, application of standards in other courses, and references. So in this project, I'll be working on creating functions for real-life parabolas, and I'll be explaining how I completed the phases, the results, processes, how they are related to standards, how they can be used in real life, and how they can be applied in other courses. This is my school, Niva International School. This is my teacher's name, Mr. Freddy, that's what we call him. And this is the date due. The keywords are fountains, water, arcs, and maybe quadratic formulas and more. So to start off with introduction, what is this template about? This template is about practicing skills to find the functions from real-life parabolas, working with it, solving it with it, creating our own parabolas, and solving it and getting the quadratic functions out of the parabola. So, how did I do it? We were given two phases for us to practice, and in there contained the instructions we had to follow. And I used the standards and lessons from the class I learned to apply and work with the phases that were given. My objectives for phase 1 was to practice and warm up the skills and graph the equations with the information given to us. For phase 2, since there were two parts, they're quite similar, but the first part was to level up a bit more and write our own equations, and the second part was to completely make our own arc and solving it and like getting the results ourselves. My limitations in this project were the measurements of the height and distance of the arc for phase 2 that I measured were not 100% accurate because obviously they were made from water, and like yeah, I have a little bit problem with that because water is not always solid. And the other thing was I wasn't able to make a starting point from the ground because the water came from a hose in my garden and the hose is not underground. Next is the methods. So before phase 1 of big project, we had to learn the lessons and standards to apply to phase 1 because we needed the starting skills or like the techniques to solve the equations and be able to move to the next step. So in phase 1, after we have learned most of the standards needed to start the big project, the phase 1 was about the fountain in Germany, and it contained the information of the distance and the height of the fountain. So according to the instructions given, we had to solve the formula, which was y equals to a bracket x minus m bracket x minus n, and find the quadratic formula and solve it and put it in decimals, and we will get the ARC in the website. Next, in phase 2, which we did not need to send, there were two parts of the second phase. I'll call it part A and part B. Part A was to take a photo of a water arc, which I chose from my garden. And after taking the photo of the water arc, I had to measure that water arc to find the distance and the height. And after finding the distance and the height, I had to use the distance and the height, put it in the quadratic formula, find the A. After we found the A, we put the A back inside the formula and solve it. And the results are one complete quadratic formula, which we put it in decimals, and we will get the arc. Then we put the photo we have taken inside decimals, and bam, we see both the photo and the arc we created from the quadratic formula we have found. So for part B was to create our own water arc that uses at least 2 water patterns in it. For this part, we needed an illustration and formula matching it. So I had to go do a little bit of research on what the height and the distance most fountains in real life were. So after I found those measurements, I had to put it inside the quadratic formula and repeat the process I have done in phase 1, and we will get the final quadratic formula and put it in decimals and then graph it. For this phase 2, I have drawn a fountain with 2 water patterns. In the final phase, and this template of big project, I had to gather the information I had from phase 1 and phase 2 and put it in this template, and it consists of what we have learned, how it is related in real life, the methods, processes we have gone through for each phase, the results, and how they're related to the standards. And one more thing, we had to show how they can be applied to other subjects in school. Next was the results. In phase 1, we were given 4.5 meters and 1 meter, which is the distance, and the starting number is 0. So the distance in the middle is 2.25 meters and 0.5, and the height of arc A is 2.5 meters and B is 0.5. Using the formula for water arc A, the formula for most of the arcs to find the quadratic formula are f x or y equals to a bracket x minus m close bracket open bracket x minus n close bracket. So this is the first step to get the answer. We had to put the starting height in m and the distance in n, and then complete the following steps. For the second step, which we put the a back inside the formula, this is the original formula. We put the a back inside here, which is this, and replace the numbers back again, and we will get the final quadratic formula. And we repeat the same thing for arc B, like this. And this is the final answer for ARC B. And after that, we graph it in decimals. These are the final graphs. And this is the graph. So this shows the fountain in Germany and its water arcs. This is the starting number and the highest point that the water reaches. And after the water reaches, it will slowly decrease and go down, and the y is 0. For the second phase, I used that same quadratic formula, which is this, and measured the hose from my garden, which the parabola jet height is 51 centimeters tall and the distance is 120 centimeters long. The x is 0, n is 120 centimeters, and we had to find the distance between 120 and 0, which is to be divided by 2, and the answer is 60 centimeters, and put it inside the quadratic formula, this. And the a is minus negative 0.14. After we have found a, we replace it back in the formula again, which this is the final. And this is my water hose in my garden. And here is the formula I have found. And the highest point which the water reaches is like somewhere over here. The x is 60 and the y is 51. And here are two more water arcs, which are shown here, are to demonstrate how to change the water level if we want to create more arcs. So to make it lower, we have to decrease the a in the quadratic form ax squared plus bx plus c. So we change the a to make the number lower, then the arc will become lower. But if we make the arc higher, we have to increase, which is 1. 1 is obviously bigger than 18. So if we increase it, that water arc will be higher. And for the second phase of phase 2, the part B, I had to design my own fountain and create my own measurements that are real life. And so I created a fountain which has 2 water patterns, and the first one is 4 meters high with a distance of 5.5 meters. And the second pattern is 3 meters high with a distance of 6 meters. And both of these water patterns are in one fountain. I will use the skills that I have found in the first phase and the part A of phase 2 and apply it in the final part. Here is the illustration of my dolphin 2 water pattern fountain. For the first pattern, we used that same quadratic formula that we used in all phases and replace the numbers inside, and we will get A. After we have obtained A, we will put it back inside the formula over here, and we will get the final answer, which is the quadratic formula for the fountain. And here, see, it matches. And for the second part, we will repeat the exact same thing using the exact same formula, quadratic formula, and find the A, replace the A back inside the equation, and we'll get the final answer. And this is the graph in decimals. Discussions and conclusions. Throughout this project, I have learned the skills about the quadratic formula and practicing it and making my own fountain. And I was able to change the water levels with the skills I have obtained. So by changing A, as I have said, I can change the level and the height of the water, and the lower the number, the lower the arc will be. And by changing C, I can change the starting height of the water depending on the numbers. So if I change C, this part will change and the arc will be different. It will never be 0 if I change the C. And conclusion, the first phase was used to practice writing and testing out the arc results, which could prepare us for the second phase. And using the knowledge I have gained, I can finish the second phase and graph the graphs in Desmos and make this template perfect. So the first part of the phase was very useful for the second part and this conclusion, because I can use the water from the hose to be a fountain stimulator to test out the angle, flow, velocity of the water, and things that are related to how high the water should reach and where it should land if I wanted to be an architect making fountains. And here are the common core standards I have learned in quarter 2. ASSE2 was to use the structure of an expression to identify ways to rewrite it. And for this standard, I have used this example, which is really similar to the quadratic formula I used throughout the phase 1 and phase 2 of the big project. Remember, y equals to a bracket x minus m close bracket open bracket x minus n close bracket. And we use this skill to apply to the project. Then for this example, we use the -2 and times it into x squared and times it to -1x, and the answer will be -2x squared plus 2x. It's plus because when you put negative and negative together, it will turn positive, and plus 0 is plus 0 because there is no starting height, or you can say the starting height is 0. For ASS3A and 3, I used the example 2x squared plus 5x plus 3 in this, and I had to learn how to produce an equivalent form of an expression, and I had to reveal and explain the properties of the quantity represented by the expression. So for this one, I found the common factors of this equation, which is 5 and 3. Then answer it. And in this standard, we had to factorize the form x plus 3 and x plus 1 is an example. And we had to put x plus 3 equals to 0, and when we move the 3 to the other side where the 0 is, the 3 will become a -3, and when we put 1 to the other side, it will be -1, and reveals the x-intercepts of the equation, 2x squared plus 5x plus 3. And for this standard, I had to use the skill completing the square to find the maximum or minimum value of the function it defines. So to complete the square, I had to move the c from the standard equation ax squared plus bx plus c, move the c to where the y is, so it will turn into y equals to -2, and then use the b from the b x and then divided by 2 and square it. And this is the answer. The answer is the minimum or maximum value of the function. It defines x and y intercept. There will be 2 answers. And for this one, ASSC 3C, I had to learn the skills to answer this, which is mostly related to exponential growth and decay, like adding, subtracting, multiplying, dividing the exponents. Arithmetic with polynomials and rational expressions. For APR, I've learned that we had to replace the equations or numbers of the letters into the equations that are given. So here is P plus Q. So we have to use the P, which is negative 3x squared plus 2x plus 5, plus Q, which is negative 3x minus 7. And here's the results, which is a quadratic function. And here AREI 4 and 4a, which is using the method of completing the square to transform any quadratic equation in x into an equation of the form x negative 4 squared equals to q. So I used this quadratic formula. So I had to use the method complete the squares and go through here, here. And in this standard, there will be a square root. So we have to solve the square root, and there will be 2 answers since there is a negative and positive. So we have to solve it. And here is AREI 4b, solve quadratic equations by inspection, taking square roots, completing the square, the quadratic formula, and factoring as appropriate to the initial form of the equation. So we have to know the knowledge of taking square roots, completing the square, quadratic formula, and factoring. So here is taking out the common factors and equal them to 0. When 5 is moved to the 0, it will turn into positive, and when negative 2 is moved to 0, it will turn to positive. And here is AREI 7, which is solve a simple system consisting of a linear equation and quadratic equation in 2 variables, which is quite the same thing. And here is graph linear and quadratic equation functions and showing intercepts maxima and minima, which you can say maximum and minimum, but we did not use this standard. But I'll show you an example in which we use the equation negative b over 2a equals to the example I've given here, and we will find the x coordinate. And after we found the x coordinate, we have to put it back to the original function, and it will reveal the x and y. The x and y is the maximum or the minimum of the quadratic function. Here is FIF8 and A. Use the process of factoring and completing the square in a quadratic function to show zeros, extreme values, and symmetry of the graph, and interpret this in terms of a context. Here is an information which is also a quadratic function. First we have to find the x by using that same equation, negative b over 2a equals to x. Finding the x, putting it back into the equation, and the final coordinates are 0.75, which is the x, and y is 3.685. Here are both FIF8b and FIF9. This was applied into the project. And I can also use the standard above to find out the example question, which function gives you a higher income from this quadratic function and this. So we have to find the answers to this quadratic function, which will be a maximum or minimum, and it will be the x and y, the highest point of the graph. So finding the x, negative b over 2a, replacing it back and getting the final equations and putting it in decimals, and we will get the final answer. Here is linear, quadratic, and exponential models. In FLE3, we have to observe using graph and tables that a quantity increasing exponentially eventually exceeds a quantity increasing linearly, quadratically, or more generally as a polynomial function. This standard you must graph it in this website decimals, and you will get two intersecting graphs, which is a exponential growth or decay and a quadratic function. Here is the real number system. This example contains the NRN 1, 2, and 3 standards, evaluating, which is also adding, subtracting, multiplying, and dividing the numbers. It will look like this, and then, but this one is not just any of your normal numbers. It is a little bit harder, and it consists of exponentials, multiplying, and square roots, and a little bit of dividing. And here is the complex number system, NCN1, knowing that I squared is equal to negative 1. So here's an example. What does square root of 5, negative 5 equal? Since it's imaginary, it is square root I in front of the square root of 5, because it's like taking the negative out of the square root. So it will be turning into I for imaginary for me. So it's NCN2. Use subtracting, multiplying methods inside. And here's an example. Find the sum of 4 plus 6i and 11 plus 2i. So both of this, we use the adding skills. 4 plus 11, we add the things that are in common. 4 plus 11, 6i plus 2i. Then leave the I with the things that are common. Next is NCN7. Solve quadratic equations with real coefficients that have complex solutions. And here is a example question. For this one, we had to use the quadratic formula, negative b equal to square root of b to the power of 2 negative 4ac over 2a. Oh, here I forgot to put something, but it's okay. And here is the results, which are the two numbers because they'll be both positive and negative. And here is the special one, application of standards in other courses. So the math skills we have learned throughout this big project and throughout the quarter, I can use it in my world history class. And here, for example, if I wanted to make a small or shrunk model of the Arc de Triomphe with the exact measurements but smaller or shrunk, I have to get the measurements of the arc, the inside of the arc, which is like this passageway thing, and put it in that very very important quadratic equation that we use in every single phase. And I have found out that the front vault, which is this part of the arc, is 29.19 meters high and 14.62 meters in distance, and use the information we have got, or the skills from phase 1 and 2. So here, the exact same thing, going through the same process, finding the A, replacing the A back inside the equation. So if I want to make the equation smaller, I can adjust the A to make the equation smaller and bigger. Here is the equation of my Arc de Triomphe. I've put it in decimals over here, and I've compared it to the photo of Arc de Triomphe I have found in the internet, and it shows where the highest point is, and it clearly matches the Arc de Triomphe. And here are the list of the websites and sources I have used, which is Shmoop, Google, Desmos, Edmodo, Arc de Triomphe, Paris.com, where I got the information from, parispass.com for the photo. And this is the end of the project, and thank you for watching my video. And if you have any questions, please ask me through my email, and thank you.